Hello, my name is Alyssa Dahlman, and I was a source protege this past summer at UCAR. I'm working on a project with my mentor, Dr. Nicole Lewandowski from the University of Colorado at Boulder, on a project called Searching for the Blob, Physical and Biogeochemical Characteristics of the North Pacific Marine Heat Wave in Ocean Models. So just to start off, let's address what the North Pacific Blob was. The North Pacific Blob was a marine heat wave that occurred from July 2013 to June of 2016. Observations of the surface ocean indicated the blob was associated with warmer than average sea surface temperatures and higher than average aragonite saturation state, which is a measure of ocean acidification potential. The image provided in the introduction shows an overall snippet of what the blob looked like in sea surface temperature anomalies. As you can see, the magnitude of the sea surface temperature anomalies almost exceeded 3 degrees Celsius during this time period, and is located off the western coast of North America. This project explores the physical and biogeochemical manifestations of the blob in various ocean models. To address the research problem, it is currently unknown whether state-of-the-art ocean models are able to actually capture or reproduce the physical and biogeochemical characteristics of the blob. This work focuses on analyzing the evolution of the blob using physical and carbonate chemistry simulation output from various ocean models. 4 ocean models from the Climate Intercomparison Project Phase 6, Ocean Model Intercomparison Project Phase Version 2 were analyzed. These various models were the CESM2, MRI ESM2, EC-3, and the NOR-ESM2 LM. These are key, there's key variables that we use to inform us the physical and biogeochemical changes during the blob event. For physical, we looked at sea surface temperature anomalies and also the vertical profile of temperature in the ocean. We also looked at the saturation state of aragonite or omega-aragonite, which determines whether calcium carbonate shells will stay intact or dissolve due to ocean acidification processes. The last variable we also focused on was dissolved inorganic carbon, or DIC, which is the sum of aqueous carbon species in the ocean, such as carbon dioxide, bicarbonate, and carbonate. We also use surface observations to help analyze the models and use it as a verification tool. The first thing we looked at were sea surface temperature anomalies. In section 4, we discussed the sea surface temperature anomalies and the outputs that were provided from each of the ocean models. Each of the OMIP2 simulations are actually able to capture the sea surface temperature pattern associated with the blob. However, the spatial pattern and the magnitude of the sea surface temperatures did vary across the models. The CSM2 was the model that produced the smallest area and the lowest magnitude of sea surface temperature anomalies. The MRI ESM2 actually had the highest magnitude and the largest blob overall. In section 5, we look a little bit more in how the models were able to capture ocean acidification and if it was able to relate to the observations. All of the models are actually able to show an indication of ocean acidification being relieved through the 2 variables of omega-aragonite and DIC, which is overall in agreement with the observations. The CSM2 was the model that was most accurately able to capture the carbonate chemistry from the anomalies from the observations. This is overall significant as ocean acidification is a very harmful process for marine life and ecosystems in the ocean, and it's interesting to see that's being relieved from an event like this. The last thing we focused on was the vertical profiles of the various outputs from the models. The reason we use this is because there's very limited observations from this event, and the models help us gather a bigger understanding of what was going on in the vertical profile during this event. The 2 models that we focused on was the CESM2 and the MRI ESM2, which indicated that the largest variations in the physical and biogeochemical state occurred only in the top 100 meters of the ocean. This implies that most of the changes associated with the blob were only influenced near the surface. We also are able to observe the largest variation in the vertical profiles only during November and December of 2013 and January and February 2014. Overall, the models were able to reproduce the blob sea surface temperature anomalies and are similar to observations, but there are variations between them. The models also indicated that ocean acidification was being relieved during most of the period, which is in agreement with the observations. Lastly, from analyzing the vertical profile, it suggests that the blob only was influential around the first 100 meters of depth in the ocean. At the bottom shows my references used in this poster, and you're more than welcome to visit and chat with me at my poster session on January 23rd from 6 p.m. to 8 p.m. And I'd be happy to take any questions from there. Thank you.